Let's compare some of the key formulae and rules about series and parallel circuits that you need to know for your exams. We'll work with these simple circuits involving two lamps as we do. So first, what's the relation between the currents of these components, and what would the total current between them be? Well, let's suppose in the series circuit, the current through one lamp is I1 and the other is I2. Then how does this relate to their total, I? Well, when components are connected in series, they will have the same current flowing through them. And then when a circuit is just a single closed loop, we will have the same current throughout. So in this case, I equals I1, which also equals I2. So the current through each lamp is the same as their total. This is because we have the same charge carriers flowing through both lamps. Then for the parallel circuit, let's suppose the current on this branch through the middle lamp is I1 and through the bottom lamp and branch is I2. Then the total current is I, and this total would have been split up between the two paths as charge carriers split at the junction. This means the total current is equal to I1 plus I2. So in parallel circuits, we have to add the currents together, while in series circuits, the currents will be the same. Now let's do the same for potential difference. In our series circuit, let's suppose the potential difference from the cell is V, and then the potential difference across the lamps are V1 and V2. Here, the energy from the cell is split across these two lamps, meaning that V is equal to V1 plus V2. Or in other words, the total potential difference across the two lamps is found by adding together their individual potential differences. Then in the parallel circuit, we also have a potential difference of V from the cell and potential differences of V1 and V2 for the lamps. In this case, the potential difference across each branch will be the same. So we have that V is equal to V1, which is also equal to V2. So unlike with the current, it's in series that we add the potential differences together, and in parallel when they're the same. Now for how we would find the total resistance in series and parallel. In series, if one lamp has a resistance of R1 and the other a resistance of R2, then their total is R1 plus R2. Charge carriers have to pass through both components, so we have to add their resistances together. Then in the parallel circuit, let's again label the resistances as R1 and R2. At GCSE, you won't need to be able to calculate the total resistance in a parallel circuit, but you need to know that it will be less than both R1 and R2. So resistors in series combine to make a larger resistance, while resistors in parallel combine to make a smaller resistance. We can also compare the effects of adding resistors and other components with resistance in series and parallel. So when we add components in series, we're adding their resistance to the total resistance. So the total current decreases. If we're connecting lamps, they would be quite dim, as the decreased current is reducing the power supplied to them. But when adding components in parallel, we're causing the total resistance to decrease. This means the total current increases. In fact, what's happening is that we have the same current along each branch of the circuit, which are then adding together to make a larger total. For the case of adding lamps, since we have the same current and potential difference through each one, they would all be the same brightness, which would be true no matter how many lamps we added. Make sure you're able to recall all of these rules for your exams, as they will help you with many different types of questions. But what's one more key part of circuits that we need to remember the distinction between series and parallel components for? We need to consider this when measuring the current and potential difference for a component in a circuit like this, using ammeters and voltmeters. First, ammeters are always connected in series with components. So we would want to connect the ammeter here, in series with the lamp. This is so that they have the same current. The ammeter would also have a very low resistance, so it doesn't affect the total resistance of the circuit. Then voltmeters are always connected in parallel with components. So we would connect a voltmeter here, in parallel with the lamp, meaning that they will have the same potential difference across them. This will also have a very high resistance, so that it again doesn't affect the total resistance of the circuit.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!